Hi, this is Todd with Laying the Mat. In this video, we're going to look at how you can find the surface area of a cone. So we're going to walk you through some of the key terms, step by step how to do it, including the formula, and then we'll give you a few examples so you can check it out yourself. So that's coming up next on the Laying the Mat. All right, so in this video, we're looking at surface area of a cone. So the first thing we need to look at are a couple of the key terms when we're working with a cone. So the first thing is the height. The height is literally just the distance from the bottom of our base all the way up to the point of it called the apex. So that's the first thing, is the height. Radius is the distance halfway across the circle, or the distance from the center to the edge. And the slant height is just our distance from the point or the apex to the edge of the circle. Now our formula to solve surface area of a cone is really two parts. The first part is going to be 3.14, which is the number we're going to use for pi, times radius squared. We're going to take that answer and we're going to add it to the following, 3.14, which is pi again, times radius times the slant height. The 3.14 times radius squared, that's really just the area of a circle. So what we're doing there is we're trying to find the area of the base. And the area of the base in this case just happens to be a circle. So when you're looking at the cone, the bottom part of this cone, that's what we're finding right there. So we'll find the area of that, and then we're going to add that to this other number. This is 3.14 times the radius times the slant height. That's going to give us our lateral surface area, or basically the side part of our cone. And we add those two together. We have the area of the bottom and the area of the side. That will give us our surface area. So here are four examples, and this is example number 1. And these are going to be pretty straightforward. So let's say we have a cone here. It has a radius of 3. So in this case, it happens to be 3 meters. We also know the height of this. In this example, the height is 4 meters. And so the last thing we have to find is what's the slant height. So in this particular example, the slant height is actually going to be 5 meters. So what we would do is we would take our equation we talked about earlier, and we're going to plug in those numbers. So it would be pi times radius squared. In this case, the radius is 3, so it would be times 3 squared. And then the other parenthesis would be pi times the radius is 3, so it would just be times 3, and then times the slant height, which is 5. We'll go ahead and solve both our parentheses. So on the left side, we go pi times 3 squared, and that answer is going to be 28.26, and that would be like meters squared. The other side would be pi times the radius, which is 3, times slant height, which is 5, and we get 47.1. If we just add those two together, we'll get 75.36. That would be meters, and that would be squared. And that would be our surface area of that particular cone. So here's another one. So this is example number 2. We first look at the radius, that distance from the center to the edge of the circle. So in this particular example, the radius is going to be 4 meters. The height, now I know it didn't quite make it look like this, but we're going to pretend that it's 3 meters tall. And our slant height, again, is going to be 5. So we have the same slant height of 5 meters as we did on the previous problem. Matter of fact, I'm using 3, 4, and 5 just like the previous one, but the answer is going to be a little bit different. So the first part, area of the circle, is pi times radius squared, or 4 squared. The second part is going to be pi times radius, which is 4, times slant height, which is 5. So when we multiply or solve the first parenthesis, we end up with 50.24. When we solve the second parenthesis by going pi times 4 times 5, we get 62.8. We simply just add those two together. When we do that, we get 113.04, and that would be meters squared, and that would be your surface area of that entire cone. So we have 2 more examples. So here's example number 3. On example number 3, again, we start with the radius. And on our radius, on this particular problem, we have 6 centimeters. When we look at the height, we have 8 centimeters. And then the final thing is the slant height. And in this particular case, the slant height is going to be 10, so 10 centimeters. We have our equation, so we start plugging in the numbers. We go pi times radius squared. Our radius is 6, so we times 6 squared. And on the other side, we have pi, 3.14, times 6 because it's the radius, and then times 10 because it's the slant height. On the left side, when we multiply 3.14 times 6 squared, we get 113.04. We multiply pi times radius times slant height, we end up with 188.4. Just add them together, and that is your volume, 301.44, and that's going to be centimeters. It's squared, not cubed, so squared. Last one, example number 4. Again, we start with the radius, or at least I like to start with the radius. In this particular case, the radius is 5 meters. Then we're going to look at the height again. In this problem, the height is 20 meters. Okay, so pretty tall cone. The slant height is 20.6 meters, so pretty close to the height. We plug in our numbers. So we got 3.14 times 5 squared. That's going to give us the area of that circle. Then we're going to go 3.14 times 5, which is our radius, and then times 20.6, which is our slant height. When we do that, we end up with 401.92, and that is going to be meters squared, and that would be our slant height. Now, I didn't put it on here, but on the left side where the circle is, that would have been 78.5, and on the right side, it would have been 323.42. Well, hopefully the video was helpful. If it was, please give it a thumbs up, and we'd love it if you would subscribe to the channel. That'd be awesome. So until next time, we'll see you on the land of math.